Hello, you guys. The road to 5 subscribers, hopefully. So today, this is lesson 10. We're changing scales in scale drawings. So we're going to be exploring different scale drawings of the same actual thing. Okay, ignore that one. Okay, there you go. So it's same plot, different drawings. So here we have a map. Oops. Here we have a map. And they say that the actual base of the triangle is 120 and the actual height is 90 meters. And they're saying what the area is. So the area would be just 90 times 120 times 1/2, which should be 5,400 meters squared. You could check my math. I try to use a calculator just so I could do it fast, just to make sure. Okay, so in class, I will give you one of the scales to use. One of these. So each person or each team is going to be making a scale drawing of this triangle, but using a different scale. And we're going to see something very, very interesting of what happens to the shape based on the scale that we have. So let's say that I got 1 centimeter to 5 meters. So I need to make a scale drawing of this. So for every 5 meters, I should have 1 centimeter. So I'm just going to draw it here next to it. Like that. Perfect. Looks so beautiful. Okay. So I know that for every 5, I should have some centimeters. So I noticed that it should be getting smaller because this is 120 and this is 5 meters. So I should be dividing by 5 here. So dividing by 5. So if I divide by 5 there, this should be 24 meters because 24 times 5 is 120. Yeah. And then how many 5 meters? Well, I know that 9 times 5 is 45. And I know that 45 is half of 90. So 18 times 5 should be 90 because 9 doubled is 18. So that should be 18. Sorry, you might hear my mom in the background. Oh my gosh. So we have 18 meters and 24 meters. There you go. This is a scale drawing of this scale. So now we have to find the area of that scale. So that should be 18 times 24 times 1/2. And I believe that should be 432 times 1/2. And then that should be 216 meters squared. Beautiful. So what is the area of the triangle? My corresponding sides were 18 meters and 24 meters. So the area of the triangle is 18 times 24 times 1/2, which should be equal to 260 meters squared. So everyone in class should have made one of these at different scales. And you're going to see right now what exactly that makes. Now, if you notice, wait, did I get lost? Oh, I did. Okay, perfect. Okay. I didn't get lost, I mean. So, let me cover this really quick. So it's asking how many square meters are represented by 1 square centimeter. So it's basically the formula is that you want to have the area of the big one divided by your scale drawings area, and that should be giving you your square meters of how much you should have. Here's all 4, and you're about to see a pattern going on right here. So you're going to notice that this is the big area divided by the area of ours, and then here's another one, here's another one, oh, and here's another one too. And you're going to see here, if you put them in order, you can kind of see, like, here's the biggest number, and it gives you the lowest square meters. This one's the lowest number, and look, it gives you the highest meters squared. And you're about to see right now with a picture what that does, what that scale factor did, which is like very interesting. Oh, that lag. There you go. Okay. Okay, so after everyone in your group is finished, we're going to order the scale drawings from largest to smallest. And what do you notice about the scales when your drawings are placed in this order? So here's each scale. Here's each scale in order. 1 to 5, 1 to 10, 115, 120, 130, and 150. And the areas for each one of them. And you notice instantly it goes from big to small. Let's see. How does a change in scale influence the size of the drawing? And you see, oh my gosh, the size instantly starts going down the bigger the scale is. Look at that, 50 meters turns into a small triangle. But as you lower the scale, 30, 20, 15, notice the triangle increases in size. Look at the drawing with the scale 1 centimeter to 5 meters and the 1 centimeter to 15, these two. How do the lengths in these two drawings compare? You could see that this is times 3. Yeah, this is 6 times 3 is 18, 24, or 7 times 3 is very close to 24. This is like 3 times more bigger. Or wait, no, this one's 3 times bigger. Yeah, than the 15. And that makes sense because 5 times 3 is 15, so it's 3 times bigger. Or more than 3 times bigger. Like the area just increased, like, oh my gosh, look at the area too. Area is 21 meters squared and 216. The area is like almost quadrupled. Let me actually see. Yeah, it's almost like times 11 times higher. 11 times higher. Interesting. And the same thing, like this is the biggest triangle, and the 1 and 50 centimeter, that's the smallest triangle. And you can see, let me zoom in all the way. It's 1.8 and 2.5 meters. It's so small, and the area is so small. Let's see. And an explanation on to why this is true, I'm going to show you guys a picture, and you're going to see right now. Okay, imagine this little line was 20. And imagine that this little line was 40. And I told you, hey, I want you to give me lines until you reach 120. You're about to see why if you have a small number, you're going to get a bigger drawing, and why if it's a bigger number, you're going to get a smaller drawing. Okay, let's go. So 2, 20, 40, 60, 80, 100, 120. Each line is worth 20, and I just got to 120. It took 6 lines. And now if you notice the green one, 40, 80, 120. It only took 3 lines. So if you have a bigger scale, you're gonna, more is placed in the blocks or the lines or the squares. It takes up more space or less space. What's the word? You have more in each given line. And if you notice a smaller scale, you have to draw way more to get to whatever meters or inches you need, which makes sense because the smaller the scale is, the bigger the drawing will be and the bigger the area will be. The bigger the scale will be, the smaller the drawing should be because it takes up way more. You need way less you need way less to actually make the drawing. Yeah, it's very interesting. Based on that scale, you can literally figure out how big or if it's going to be small. Oh, a new drawing of the playground. I don't even think we're going to get to this in class, but hey, I'll show it to you here. So here we have here a scale drawing of a playground. Notice it does not have any lengths, but since we know the scale, we probably can have an idea of if it's going to grow or if it's going to be small. So this is a scale drawing, so it's not the real one. The scale drawing with using this scale. Now we have to make another scale drawing of the same playground at a scale of 1 meter to 20 meters. There's 2 ways to do this. First method, well, you have to make the real one first. So in order to make the real one, we have to multiply by 30 with this scale because that's the scale for it. So we got to multiply by 30. So if we multiply by 30, well, technically it should get bigger. So let me make it, there you go. It should get bigger. Can I increase the size? That looks really small. Whoa, come on, don't fail me now. There you go. It looks like a shoe. I like it. There you go. And there you go. Now this is the real one. This is the real one. There you go. Now, looking at this, like, hey, this got much bigger. And we did times 30. Well, now this one, to 20 centimeters, or 20 meters, well, that's smaller. So shouldn't we be dividing by 20? Dividing by 20 now? Because it's getting smaller, I guess. Or the idea is that it should be getting smaller. But you're about to see something because it's not actually getting smaller. It's just the idea is that we use the real one and then we use this one. So it actually did get bigger. It did get bigger, but now it's going to get smaller. But interestingly, you're about to see this. Let me see if I could decrease the size. Let's see. Oh, it's all messed up. Okay, we're just gonna, whatever, it's fine. So this is a new scale drawing of dividing by 20. But I want you to realize is that we could have just done this. So imagine this purple one was there and this red one was the one we just did. Both of these are the scale drawings. I want you to realize we could have just multiplied by 30 and divided by 20 like this instead of doing it each separately. This is the same as times 3 over 2. I want you to realize that this is equal to 1.5. This is scale is greater than 1. That means that this one is bigger. Both of these are scale drawings, and guess what? Since they have a common scale factor and they have corresponding sides and congruent corresponding angles, these are also scale copies. These two scale drawings are scale copies of each other. So I want you to realize that we're multiplying by 3 over 2. It's getting bigger. This is bigger. I mean, the red one, the scale of 1 to 20 meters, is bigger than the original one, than this one. But yeah, that's one way to do it. But here's another way. So the idea is that we're going to use 1 centimeter to 20 meters. And then let's make it purple. 1 centimeter to 30 meters. So the idea is that we want to make a new scale drawing using this one. And what we can do is turn this one to have 30 meters. So I know that if I were to cut this in half, if I were to cut that 20 in half, let me cut it in half. It would be a 10. Oh, it would be a 10. And then half of 1 would be 0.5 centimeters. Now, isn't 20 plus 10, 30? We can actually combine our two scales together and we'll get 1.5. This plus this is 1.5 centimeters to 20 plus 10 is 30. This scale is the 30 over 20 scale. Notice here's the 30 and this is the 1.5. Here's 1.5. That's the scale factor. So in reality, you're saying, hey, this is 1.5 times bigger than the original one. So this is 1.5 times greater or bigger than the scale drawing here of this one. So how did the two scales drawings compare? Well, the new one with the 1 centimeter 20 meters, if you make a new scale drawing, it is actually bigger. The new scale drawing is bigger because the scale is 1.5 or times 1.5 or 3/2. Yeah. It's very interesting. All because we know that the scale factor is times 30/20. You know that it's going to be bigger because it's over 1. So it's going to be big. Since the scale is much smaller, and like we learned before, 20 is smaller than 30. So definitely the scale drawing, this one, is going to be bigger than the 31. Absolutely it will. It's so cool that you could literally decipher and figure out all of this just with that scale. I think I need to delete this slide. It's just sitting here. Okay. So key takeaways here. The new scale drawing is a scale copy of the original, is what we just said right now. The scale factor from the original drawing to the new drawing is 3/2. We just figured that out. You multiply by 30 and then divide by 20 to get the same result as just multiplying by 3/2. The drawing with a 1 centimeter to 20 meters is larger than the drawing with a scale of 1 to 30 because it's smaller. Remember, it takes more 20s to get to what we need to get to. Because that means that the drawing has to be bigger. Yeah, I think that's pretty much it. So the whole point here is that how does your new map compare to the original map? This is the original, and the new map has this scale. Well, if you notice that the scale or the scale is small, that means that the new map is going to be bigger. The new map is way bigger. And how much actual area does 1 centimeter squared on your new map represent? If this is a bigger new map, that means that the area is going to be way larger because larger shapes have larger sizes. And if you multiply them and find the area, it's going to be much larger in there. And the actual area did the 1 centimeter square on your original map represent? Well, this map, realize that the shape is going to be way smaller. So that means the area inside is going to be much, much smaller. Yeah, very interesting. Very interesting. Well, y'all, that's pretty much it. It's really cool to see that you can use, get given a scale drawing, you can now create a scale drawing that shows the same thing at a different scale. You can create another scale drawing that shows the same thing at a different scale. Yeah, and you can find it actual areas. And they vary in size depending on the size of your scale. Very cool. All right, y'all. Have a good one. Hasta luego. Like and subscribe. The road to 5 subscribers, hopefully. I will assign you an I Already My Path lesson. Hasta luego. Bye-bye.